traditional design patterns deals with this type of object creation mechanism. And now coming to the topic, it is singleton design pattern. Singleton design pattern is one of a creational design pattern that helps you to create only one object for a class. It ensures that it and only one object is instantiated for a class. So while creating a singleton class, these two properties should be there. So a singleton design pattern shares the first property is that it should ensure that there is only one instance created. So we all know that object is used to access the classes. So we can control a class, or we can control a methods in the class using that object. So that is the situation. So if we create more than one, like we know that we create more than one objects, or we use it to do different type of means controlling different types of situations to inside on a class. So for like controlling that access, that means if for this situation I have for example, if I had to make this class as a common class and no other outer class or subclasses should create an object for this class, that means it should have only one object which should be shared among the application. So this is the one property, the major property that a singleton class should have. And another one is that this instance should be globally accessed. That means if I create an instance for a singleton class, that instance should be shared or accessed to the entire application. That object should be shared among the application. So I think it is clear. So these two properties should be there for a singleton class. And how do we implement? This is a structure of a singleton class. So you can see that the singleton class is a public static class, and the next line is object instantiation. The object is of a private static type, and there is a constructor and other method, which is also static, that is get instance method, which returns the instance that are generated, that is created or instantiated. So here we can see that we all know that what is a constructor. The constructor's basic job is to create objects. So if I create an object class A is equal to new class A, the default constructor inside class A will create an object A. So basically the constructor is responsible of creating an object. So here if we all know that the default constructor is always public. So if we make a constructor public, it can be accessed by the outside class. So the first property, that is no more than one instance should be created, will be violated. So in order to achieve that, we have to make that default constructor or that constructor as a private type. So making it private, the visibility remains inside the class. Okay. So the first thing is making that constructor private, and then making a static method. So why are we making a static method? The property of a static method is that if we make a method static, we know that it will share the same memory, and it is easy to access. We don't need an object, a help of an object to access that method. All will be familiar with that. So for accessing this get instance method, we only need singleton dot get instance. We only need this code to invoke that get instance method inside a singleton class. And we all know that static method can only return a static variable. So now the main part, the instantiation part. So the first line of code, private static singleton s instance is equal to new singleton. This is the way a singleton instance is created. As it is created inside the class, the no outside word can access, like override that object. So here by making it static, we know a static. We know that static member can only return static variable, so it is static, and the object is instantiated there. Now there is another implementation there. In the previous one, you see that the instantiation is directly made before the invocation. So before the get instance method. So here the instance is created but not instantiated. Okay, so it is instantiated inside the get instance method. So first we check that if the instance is null, that means if the instance is already instantiated or not. If it is not instantiated, then a new object is instantiated or created, and then it is returned. So this is the second implementation. So basically, as we all know that, as we came to know that there will be two type of implementation. One is eager instantiation, and the other one is lazy instantiation. Eager instantiation is the first one. So basically, eager instantiation means that the object should be already inside the memory or already being created and instantiated. Only after that it should be invoked, or before invoking that object should be ready. That is the main property that an eager instantiation should follow. So also it is thread safe. Why it is thread safe? So consider the situation. Um, so there is thread 1 and thread 2, and this thread 1, so first time when it is compiled, that object is created, it is residing inside the memory, and a memory is allocated, so the object is ready to use, and thread 1 is coming to use that object, and it invokes the get instance method. So and the get instance method returns as instance, an instance. So basically the object or the instance is ready to use, and the thread 1 is getting that, or get the link of that static variable, and now thread 2 starts to invoke get instance, or maybe at the same time itself, but already that object is created, so there will be no issue with sharing that instance to thread 2 also. So that is why it is called a thread safe. But the next instantiation, that is lazy instantiation is differs in object creation. So as we all know that, we know that in eager initialization already the object is created. So when the code is compiled, the object and the memory is allocated to that object. So here, whether it is used or not, the object is used or not, that memory is allocated to that object. So that if it is not used, that's a waste of memory. So in order to improve the performance and utilizing the memory, lazy instantiation is used. So here you can see that in this code, the object is declared, but it is declared to null. And if you see that when that get instance method is invoked, first it checks it if it is null or not, that is it is instantiated or not. Only if it is not instantiated, then an object is instantiated, so the memory is allocated only at that part. So that's why it is called, you can we say that memory is utilized, the performance is increased. And but the thing is, here the lazy initialization, the thread is, and it is not thread safe. Why? So consider the scenario, the same scenario. The thread 1 invoke get instance. Okay, so the first line of code in method is if instance is null. Obviously it is null, the instance was not created, and then it goes to the next line, that is singleton adds instance new singleton. So here it was starting to get executed that line of code, but at that time thread 2 came and it preempted thread 1. So now thread 2 will be working. So at that point of time, thread 2 checks if the instance is null or not, and it sees that the instance is null because that thread 1 doesn't created any instance. They didn't got the chance to create an instance. And then uh, thread 2 checks if the instance is null, and it is null, and it goes to the next line, the instantiation line, and that is executed, and then that instance is returned. And after execution of the thread 2, thread 1 will be again preempted, and it is still on that line, singleton new instance, that line. So it doesn't know that thread 2 have already created an object at the previous execution, because there is no other checking. So what happens there? Again, an instantiation is occurred, and another object is created, which is a clear violence of the first property, that singleton class should share only one object. So that's why it is called that it is not thread safe. And now, how can we make a lazy loading thread safe? Like lazy initialization thread safe. The answer is through this double check and locking. Double check locking is basically means putting two checks to make sure that only one thread is executed at the function. And this is the code part, and you can see that in the get instance method the instance is checked as usual, and then there is a synchronized block. Now synchronized keyword is used to make sure that only one thread is executed inside on the block, the in what is the code inside the block. So now if a thread 1 is executing, or it's executing inside the block synchronized, any other thread coming after is has to wait only after thread 1 is executed, or the whole code inside is synchronized, then the thread 2 is allocated to that. So consider that previous equation. Thread 1 is checking if that instance is null, it is null, and then it enters to the synchronized block, and again there is checking instances whether the instance is null or not, and only it is clear that the instance is null, it will create the or it will instantiate the object. And when a thread 2 comes, it will have to wait or until the thread 1 execute that full block, synchronized block. So this is how we achieve the thread safety in lazy loading. Now the applicability. So single pattern is used mainly for, like as I earlier said, that if I have to share a common class into share among the application, in that situation we use singleton pattern. So like database, that database connection object can be shared among to the overall entire application. So that's an applicability. And then the lot of application are there for logging and like printers, hardware, like that. So these are the references I use for learning the singleton. And thank you.